Hello learners, welcome to Dr. D.Y. Patil Vidyapeeth's Center for Online Learning. I am Professor Dattatray Katore and you are studying with me Statistics and Quantitative Techniques. In this video, we are going to understand probability and probability distribution. So this is Unit 7 of your course Statistics and Quantitative Techniques. Probability. So what is probability? Roughly speaking, probability is how frequently we expect different outcomes to occur if we repeat the experiment over and over again. So this is the frequentist view of understanding the probability. So according to this particular definition, probability is how frequently we expect different outcomes to occur if we repeat the experiment again and again. So let us first understand a few concepts from this particular definition. The first is experiment. Now what is an experiment? So something capable of replication can be called as an experiment. So something which under stable condition generate a replication of outcomes, that is called as an experiment. The example of an experiment can be tossing a coin, then it can be throwing a die. So this can be the examples of experiment. Then sample space. Now this is again in relation to the experiment. So what is sample space? So sample space is listing of all possible outcomes of an experiment. The set of all possible outcomes of an experiment is the sample space. A sample space can be finite or infinite, discrete or continuous. Now what does it mean? Finite means if the number of outcomes in an experiment are countable, then they are said to be finite, and if the number of outcomes of an experiment are uncountable, then the sample space is said to be infinite. Then what is discrete and what is continuous? So a discrete sample space means the outcomes of an experiment can be counted, right? One can put a finger on one outcome after another without missing anything in between them, right? So that is discrete. For example, tossing a coin consists of two possible outcomes, head and tail. So there are only two possible outcomes which are discrete, right? And there is nothing in between them, right? So there cannot be anything between head and tail. It can be either head or tail, and that's why outcome of tossing a coin can be called as discrete outcomes. Then continuous. Continuous means when we cannot mention the outcome of the experiment in discrete numbers or discrete elements, we have to mention the outcome of an experiment over a range, right? So in such a situation, the outcome or the sample space is said to be continuous. The example is height, weight. So all the measurable variables can be classified as continuous variable, and all the countable variables can be considered as discrete variables. Event, a subset of the outcomes of an experiment. Now what is an event? We understood what is probability. So probability is how frequently we expect different outcomes of different outcomes to occur. Then we discussed what is an experiment. So experiment is something which is capable of replication of outcomes under stable condition. Then we learned what is a sample space. Now we are studying what is an event. So event is a subset of outcomes of an experiment, right? So the example, when the experiment is tossing a coin or tossing coin twice, and the sample space in this case would be HH, that is both are head, one head and another is tail, one tail and the head, and then both are tails. So these are the different possible outcomes of an experiment which consist of tossing a coin twice. An event could be that you got at least one head on the two tosses. Alright, so an event could be mentioned, could be represented, could be expressed like that you got at least one head out of the two tosses. So how many outcomes, how many elements from the sample space consist of at least one head? So as you can note in the sample space, there are three outcomes which consist of at least one head. So these are head, head, head and tail and head. So there is at least one head in these three outcomes. So out of the four outcomes in the sample space, in event there are three outcomes which consist of only one, at least one head. Thus, the definition of probability. So probability of a particular event is denoted by P of E. So P of E is equal to N of E, that is the number of elements in event E, divided by N of S, that is the number of outcomes in sample space. So this is equal to the probability. So P of E is equal to N of E divided by N of S. So this is equal to N of E divided by N. So N of E is number of elements in the event and capital N is the total number of outcomes. So this applies to special case when the sample space has a finite number of outcomes. So this particular formula will not be applicable in case the number of elements in the sample space are infinite. So this is applicable for the finite sample space only. Another assumption is that each outcome is equiprobable. So each and every outcome of an experiment should be equiprobable, means there should be equal chance of happening of each and every outcome of an experiment. So when we toss a coin, the probability, the chance of occurring of head or tail is equal, right? So this particular formula is applicable in such a situations only. Two basic probability properties of probability. So the probability, the value of the probability always lies between 0 and 1. It cannot be more than 1, it cannot be less than 0. So for every subset of sample space S. Another basic property of probability is that probability of sample space is equal to 1. Why so? Because number of elements in sample space divided by number of elements in sample space becomes equal to 1. Let me show you it on slide. Yes, so by definition of probability, P of E is equal to N of E, that is the number of elements in event E divided by number of elements in sample space. But when we calculate the probability of sample space, so this will be equal to number of elements in sample space divided by the number of elements in sample space again. So numerator and denominator are same, and therefore probability of sample space is always equal to 1. Then set theory is very handy and useful to understand the probability. So this is another view to look at the probability. So from understanding of complements of event, then union of sets and intersection of sets, we can understand the probability. So what is complement? The complement of A is everything in the sample space that is not in A. So if the rectangle box is called as sample space, that is all the elements, all possible outcomes of an experiment, and the white circle is denoted by the event A, then everything in the box outside the circle, that is the white circle in front of you, is A complement. So the blue shaded region of the rectangle is A complement. So let me show you this. So this particular region is A complement. So A complement and A both are a part of sample space, right? And together they form sample space. So what we can say from this, so the part outside A but the part of sample space can be called as A complement. So A plus A complement is equal to sample space. All right. So let us apply probability on both sides. So when we apply probability on both sides, what we get? Probability of A plus probability of A complement is equal to probability of sample space. Now we already learned that probability of sample space is equal to 1. So probability of A plus probability of A complement is equal to 1. So this is the third theorem of probability 1 we learned. So the first theorem, first principle we learned is that probability always lies between 0 and 1. The second theorem we learned that the probability of sample space is equal to 1 always, and here we learn that probability of an event and its addition with the probability of its complement is always equal to 1. So probability of an event plus probability of its complement is always equal to 1. So this is the theorem we have already seen on the previous slide. So probability of A complement is equal to probability of 1 minus probability of A. So example is given here. So if A is the event, that probability that a randomly selected student is a male student and the probability of A is 0.6, what is the probability of A complement? So let us assume that the student is either male or female, right? So let us draw the sample space once again. So this sample space, this rectangular box represent the total number of students, right? And this particular event A represent the male student, so there would be female students as well. So if this is the sample space and if the event A represent the number of male student, then A complement will be the event that represent the number of female students. So clearly probability of A plus probability of A complement is equal to 1. So we know that probability of male student is 0.6 plus probability of A complement we have to calculate. This is equal to 1. So from this we get probability of A complement equal to 1 minus 0.6, it is 0.4. Then union of A and B. So this is denoted by this particular symbol A union B. So the union of A and B is everything in the sample space that is in either A or B or both. So this white region inside this blue box is the A union B. So it consists of elements that are part of A or B or both A and B. I repeat, the white region or white portion inside the blue rectangle is the A union B. So it consists of the members in the event A or set A, members of the set B, and members of both set A and set B. So the union of set A and B is the whole white area inside the rectangle. Then we have intersection of A and B. So this is denoted by this particular symbol A intersection B, and is everything in the sample space that is in both A and B. So this common region between A and B. So the elements which are common to both set A and set B can be considered as intersection of A and B. So the intersection of A and B is the pink overlapping area. So we have an example here. A family is planning to have 2 children. Suppose boys B and girls G are equally likely. So this is as per the assumptions we have learned already for the formula of probability. So family is planning to have 2 children. Both boys and girls are equally likely. So what is the sample space? So sample space could be both boys or both girls, then first boy, second girl, first girl and second boy. So these are the all possible outcomes when a family is planning to have 2 children and when boys and girls both are equally likely. So this example is continued. So if E is the event that both children are of same sex. So let us consider this event E. So event E is the event that both children are of the same sex. So what does E look like and what is its probability? So the sample space consists of 4 elements: both boys, both girls, first boy, second girl, first girl, second boy. So out of these 4 outcomes, there are only 2 outcomes which represent that both children are of same sex. So the event E consists of 2 outcomes or 2 elements, BB and GG, that is both are boys or both are girls. Since boys and girls are equally likely, so each of the 4 outcomes in the sample space S is equal to BB, GG, BG, GB are equally likely and has probability 1 divided by 4. So these 4 outcomes are equally likely and therefore probability of each of them is equal to 1 divided by 4. So let us find out the probability of this particular event that both the children are of same sex. So probability of E is equal to 2 divided by 4. So why 2 divided by 4? Because the event E consists of 2 elements and the sample space consists of 4 elements. So 2 divided by 4, it is equal to 0.5. Then the same example is continued. Remember that event E consists of 2 elements BB and GG, that both children are of same sex. Probability of E is equal to 0.5. Now what is the probability of E complement and what is its probability? What is the complement of E and what is its probability? So clearly, if E is the event that both the children are of same sex, then E complement would be the event that both the children in a family are of different sex. So in the sample space, there were 4 elements BB, GG, BG and GB. So out of them, 2 elements consist of children of different sexes. So BG and GB, these 2 elements will be there in the E complement. So probability of E complement by definition or the theorem, that is probability of E plus probability of E complement is equal to 1. So by this theorem we can find out probability of E complement. So probability of E complement is equal to 1 minus probability of E. So this is equal to 1 minus 0.5 because we have already calculated the probability of A, right? And from this we can calculate the probability of E complement. So we have calculated the probability of E on the previous slide, and therefore now we can directly calculate the probability of E complement by applying the theorem which we have studied, right? Or we can directly calculate the probability from this also. So probability of E complement is equal to number of elements in E complement divided by number of elements in the sample space. So how many elements are there in E complement? So there are 2 elements divided by the sample space consists of 4 elements BB, GG, BG and GB. So 2 divided by 4, this is equal to 0.5. So you can find out by this way or by using the theorem as well. The example is continued. We have another event here. If F is the event that at least one of the children is a girl child. So at least one of the child is a girl child. So what does F look like and what is its probability? So out of the 4 outcomes, we have to find out the outcome which consists of at least one girl. So there are 3 outcomes out of the 4 outcomes BG, GB and GG. So there is at least one girl in each of them, right? So F is the set of BG, GB and GG. Now what is the probability of F? So probability of F is equal to 3 divided by 4. How so? Because there are 3 elements in the event F divided by the number of elements in the sample space. So sample space consists of 4 elements BB, GG, GB and BG. So that's why 3 divided by 4. So 0.75 is the probability that at least one of the child is a girl child. Then remember that we have already found out event E, that is the set of BB and GG. We have already calculated probability of E, which is 0.5. We learned that event F consists of 3 elements BG, GB and GG, that is at least one girl, and we calculated the probability of F as well, which is 0.75 on the previous slide. So what is E intersection F? So what is E intersection F? So E is there in front of you, F is also there in front of you. So as we can see that there is only one element which is common to both. All right. So let us check them. So BB is not common, right? It is not BB there in F. So GG is the only element which is common in both set, right? So intersection is the represent all the elements which are part of both the sets, right? E and F in our case. So the only element which is part of both the set is GG, and therefore E intersection F is a set of GG. What is its probability? So probability of E intersection F is equal to 1 divided by 4. How so? Because number of elements in E intersection F is equal to 1, and the sample space consists of 4 elements, and that's why the probability of E intersection F is 1 divided by 4, that is 0.25. Now remember that, or recall that E is the set of BB and GG. Probability of E is equal to 0.5. F is the set of BG, GB and GG, that at least one child is a girl child, and probability of F is equal to 0.75. So what is E union F? So E union F is the set of all the elements which belongs to either A or B or both, right? So we have to mention all the elements, but we have to make sure that we do not write the common element twice. So we have to write the common element only once, right? So BB, GG, BG and GB, we are writing GG only once. Note that, because we are writing common element only once in E union F. So this is equal to sample space. So E union F is equal to sample space. What is the probability of E union F? So 4 divided by 4, that is the probability of sample space. Now what happens if we add the separate probabilities of E and F together? Do we get E union F? When we add the probabilities of E and F together, do we get probability of E union F? The answer is not, not. You don't get it. So probability of E plus probability of F is equal to 0.5 plus 0.75, which we have already calculated. So this is equal to 1.25, but we learned that probability cannot exceed 1, right? So it is 1.25. This is wrong. Why it is wrong? Because there is one element which is common in both set E and set F, and which has been counted twice when we calculate the probability by adding them together. So when we add the probability of E, probability of F together, what we get is 1.25, is because of that extra element which is common in both of them. So we have to count it only once, and that's why from this we need to subtract the probability of E intersection F. So we have to subtract the probability of 1.25. We have to subtract the probability of common element, that is probability of GG, from 1.25, so that we get the probability of E union F. So probability of E union F is equal to 1.25 minus 1. So that is what it is. Probability of E intersection F is 0.25, and probability of E union F is 1. So there are two rules about this probability: addition rule and multiplication rule. So let us first understand the addition rule. So addition rule, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B, right? And this is applicable in case the events are conjoint like this, right? Otherwise, probability of A union B is equal to probability of A plus probability of B. This is applicable when the two events are disjoint like this. Then there is a multiplication rule of probability. So according to it, probability of A intersection B is equal to probability of A multiplied by probability of B. So this is about the addition rules of probability and multiplication rules of the probability. We have understood one example by using the complements and union of the sets as well. So the probability of E union F by addition rule is equal to probability of E plus probability of F minus probability of E intersection F. So if E and F do not overlap, means they are not, they are disjoint, in that case probability of E union F is equal to probability of E plus probability of F. So thank you for watching this video. This is all about the basics of probability. I hope you have understood the basics of probability. Thank you so much for watching this video.